Okay, everybody. So if you take a look at the sheet that I just gave you. So this, we're just going to practice real quick, determining who's independent and who's dependent. And I gave you a sort of little guide at the bottom here. Okay, in order to, this is what I personally do. If you do something else, that's fine. I write, or I say this phrase to myself. I want to figure out what depends on what. Whatever is here is the dependent variable that will go in for y. Whatever goes in here is the independent variable that goes in for x. So if we look at number one says a study was done to find if different tire treads affect the braking distance of a car. So these are the two things I'm comparing, tire treads and braking distance. So then I ask myself, do tire treads depend on braking distance? That sounds weird. I don't think that's it. But does the braking distance depend on the tire tread? Yes. So that's how, oh, okay, braking distance, you don't have to write it in, but I will. So my braking distance depends on the tire tread. So that's how I know which one goes where. So my independent variable will be my tire tread. So that's what I'll put there. And then my dependent is the braking distance. Let's try another one together. So if I look at the second one down, the second one down reads, the time it takes to run a mile depends on the person's running speed. My gosh, they already basically filled out the form for me. The time it takes to run depends on the person's running speed. So this is my independent. This is my dependent. Right? If I match it up with that little, I don't know, sentence frame at the bottom, the time it takes depends on the person's running speed. Okay, you try the third one. The height of a bean plant depends on the amount of water they receive. Or the height of bean plants depends on the amount of water they receive. Again, it's already kind of set up for you. So hopefully this one's not so bad. Okay, what's my independent variable? Jake?
The amount of water.
You got it. Amount of water. And so naturally the dependent must be the height of the beans. Bean plants. Now, number 4, this is the last one I'll do with you, and then I'll give you some time to try the others. But number 4 is not quite set up with our little sentence frame. It says, the higher the temperature of the air in the oven, the faster a cake will bake. So it's up to you to figure this one out. Would you say the temperature of the air in the oven depends on how fast the cake will bake? Or would you say the speed at which the cake will bake depends on the temperature of the air? Doesn't that one make way more sense? Wouldn't the speed at which the cake bakes depend on how hot the air is? Are you with me? Yes. So speed of the cake baking would be your independent variable. Speed of cake baking. Oh, wait, did I just mess that up? Yeah, I did. Sorry. Hold on. The speed that depends on the temperature of the air. Oh, I put them in the wrong spot. The speed of cake baking depends on the temperature of the air. We'll do one more together since I just messed that one up. 5, lemon trees receiving the most water produce the most lemons. Jake. Yes, because wouldn't you say the number of lemons I received depends on how much water the tree got? You would never say the amount of water that the tree got depends on how many lemons it produced. It goes the other way, right? How many lemons it produces depends on how much water it got. Okay, so my dependent will be number of lemons depends on the amount of water. Okay, take a few minutes. You try 6 through 9, please. Yes, but since the bell has rung, look at these fancy passes I have. There's a sign out sheet right there. Okay, how'd we do? Got some? All right, let's try 6. An investigation found that the more bushels of potatoes were produced when the soil was fertilized more. So does the number of potatoes depend on how much fertilizer we got? Or does the fertilizer we got depend on how many potatoes came out? Which one makes sense? The first one or the second? I'll take your silence as a vote for the first one. Yes, doesn't the number of potatoes I got depend on how much fertilizer the plant got? Right? That makes so much more sense. Number of potatoes depend on how much fertilizer I got. So independent would be fertilizer. And then the dependent was the number of potatoes. Okay, 7. Students measured the temperature of the water at different depths in Lake Skywalker and found that the temperature varied. So you've got a lake, you're measuring different depths, seeing what the temperature is. DJ?
So the temperature of water.
You got it. Perfect. Your temperature depends on how deep you are in the lake. Yes? Okay, all right. 8, the amount of pollution produced by cars was measured for cars using gasoline containing different amounts of lead. Everybody think they have this one? So amount of pollution produced by cars was measured for cars using gasoline containing different amounts of lead. Cedric? You said independent was the amount of lead?
Yeah.
I agree with you. The amount of pollution depended on, thank you, how much lead was in the gasoline. Okay, last one. 4 groups of rats are first masked and then fed identical diets except for the amount of vitamin A they receive. Each group gets a different amount. After 3 weeks on the diet, the rats' masses are measured again to see if there has been a decrease. So what are we testing? Jake, go ahead.
Various masses be dependent on the amount given each.
Yes. So this is their, I'm gonna call it, yeah, so mass would depend on how much. Like, yeah, I'm gonna go with just the amount of vitamin A, right? Because their diet was the same except for the vitamin A. So we'll say vitamin A amount. Their mass depends on the amount of vitamin A they received, or at least that's what we're testing. Okay, do we feel fairly confident with this? Because now we're gonna step it up a notch. Don't worry, I have notes for you. Aren't these convenient? A little one-stop shop. You can just look and see. This is exactly what I'm supposed to do with this stuff. Does anybody decorate for Halloween yet?
I don't eat chocolate.
I like the candy aspect, but like not the.
Yeah, I just don't like.
I don't like Halloween, but my mom does.
I don't like it.
I'm like crazy. about it.
I don't really have an
Crazy
incentive.
about it. And I'm literally born on Valentine's Day. Like, why would that be a thing? That's what I say. I yell at her.
Decorated this weekend. I'm so excited. I would like- I love Halloween. I have what-
You always been seeing the rest of the stages, I don't eat chocolate. I have that stuff big one.
I remember you used that, and then I really this shit. Take it off your hand.
Okay, so let's take a look. We're gonna walk through these steps and we're gonna try a bunch of them together. All right, first of all, let me put this. I'm getting pretty good at staying somewhat organized. This is a first for me. Okay, so linear modeling. Step 1, determine which is the independent and which is the dependent variable. So we just practice a bunch of that. We're getting good at that. Then we're going to make a t-chart. Remember, independent is your X and dependent is your Y. Once you have some values here, all you really need is 2 sets, 2 ordered pairs, if you will. Because if you have an X and a Y and an X and a Y, my gosh, couldn't I write the equation of a line if I have 2 points? That's basically all you're doing. So once you have two values, you're going to write the equation starting off in point slope form, because all we'll have to do is find our slope and then just pick one of the points and pop it in. Transform to slope intercept form. So we've talked about that. Distribute your slope and then add the y1 over. And then we do want to write it in function notation. We'll talk a little bit more about that. Do you guys remember function notation? Okay. Well, if you take a look at these two, the only difference is that we're replacing y with f of x. So I'll talk a little bit more about function notation once we do out an example, okay? So if you would flip this paper over, I have some problems for us to try together. Okay, the first one, let's read it. For a banquet, a restaurant charges $300 to rent the facility plus $60 for each guest. Model the total cost C as a function of the number of guests N. So I know my two variables. One's going to be a C and one's going to be an N. I want to figure out which one's the independent and which is the dependent variable. So that's my X, that's my Y. Would I say that the total cost depends on how many guests are there? Yes, I would not say the number of guests depends on the total cost, right? That's weird, that doesn't make sense, but it totally makes sense that the total cost is going to depend on how many people I have. So what does that mean? That means this is going to be my number of guests. I probably shouldn't have drawn the number of guests, which in this case, we're using the variable N, and this is going to be my total cost. Let's see. They gave me, there's only one number here, 300. So how am I supposed to get 2 points out of this? Guess what? You can pick. If I don't have any guests, let's say nobody shows up to this party, how much is it going to cost me? It still is going to cost me $300 because I had to book the place, didn't I? I had to rent the hall out. So even if no one comes, if I have 0 guests, I'm still out $300. If one person comes, how much is it going to cost me? $360. Do you see that? Because I had to pay for the hall plus $60 a person. So what you can do, if you are not given values, you can create values. You could have picked any numbers here too, by the way. You didn't have to pick 0 and 1, but I might as well pick easy numbers, right? So if no one comes, that's a reasonable one. If one person comes, 360. I have 2 points. Once I have 2 points, I can write the equation in this line. And that's my ultimate goal. I'm trying to write a function that models this situation. So let's go ahead and find the slope if you haven't already. Remember, this is just X and Y. So I have 2 points, 0, 300 and 1, 360. So when you find the slope, remember, here's the formula if you don't have it written down. Do the, oh, some of you made that mistake on that quiz. When you do the slope, it's the Y's on top and the X's on bottom. I tried to catch that where I saw it. So I get the slope is just going to be 60, right? And then pick a point to use. You might as well use the 0, 300. And then we're going to put it right into point slope form. Y minus y1 equals m times x minus x1. So using that point, 0, 300. Oops. Oh, whoops. Okay. Did you eventually get this equation in slope-intercept form? Y equals 60x plus 300? So now all they want you to do is write it in function notation. So remember, that just means I'm going to go ahead and replace y with, normally it would be f of x, but I'm not using, oh, look at me. See, I even got lazy. I always switch to x and y instead of the variables that they gave me. I'm supposed to be using n's and c's, whatever. So x is, x and n are the same thing. So instead of writing f of x, I should be writing f of n equals 60n plus 300. And there is my answer in function notation. So I said I would talk to you a little bit about function notation again if you have forgotten. The letter out in front is just the name of the function. So f is just what, I'm just giving it a name. I'm calling it Fred, or I'm calling it G for George, or I'm calling it H for Henry. You're just giving it a name, that's all. So if I have a whole bunch of functions, I need a way to distinguish between them besides just calling them function 1, 2, and 3. So we just give them a letter. That's literally all this thing is out in front. It's just the name of the function. And then whatever is in the parentheses, that's just what I'm replacing. So I can just replace n with the number of guests that I want. So when they say model the total cost C as a function of the number of guests, this is what they mean. It depends on how many guests I have, and that will give me my total cost. Does that make sense? Is this okay? So far, so good? Okay, you say yes. Then I get worried. Number 2 is the same idea. It just happens to have really big numbers. Don't get thrown off by the big numbers. Whatever, we have calculators to handle big numbers. We got lucky in the first one, they were small enough we could do them in our head. Okay, let's read the second one and see what's going on. Do not get discouraged because there's big numbers. Let's see. Number 2, what do you got going on here? All right, from 1990 to 1996, the population of Oregon, or is it Oregon? I don't know how to say it. Is it Oregon? Nobody says Oregon? But isn't it the Oregon Trail? That's what we all said. Whatever, I'm saying Oregon. You say what you want. Anyway, the population increased by about 60,300 people per year. In 1996, the population was about 3,204,000. Write a linear model for the population P of Oregon from 1990 to 1996. Let n be the number of years since 1990. Use your model to estimate the population in 2018. Okay. So we have 2 variables. We have P for population and N for number of years since 1990. So let's talk about this. Do the number of years depend on the population, or does the population depend on the number of years? First way or the second way? Second way, yes. The population depends on the number of years. So that means N will go in for X and P will go in for Y. Okay, now this time they did give me some information. Let's read. Okay, so for this 6-year span, it was increasing at 60,300 people a year. In 1996, the population was about 3,204,000. That's a point on my line. They gave me a specific bit of information. They said, hey, here's the census from 1996. We had this many people. So let me ask you, for this sentence, what do I put in for N in my little chart here? What does N stand for? Cedric? Keep going. There's more to it.
Number of years since we.
So if it's 1996, what am I putting in? Go ahead, Cedric. 6. Exactly. So I'm putting in 6 for N, and then the population that they gave me. 3,204,000. What I don't have though is a second point, but I have enough information to figure out a second point. I do know that read what it says, from 1990 to 1996. So in that window of time, it was increasing by 60,300 people every year. So can I just say, okay, well, I know what it was in 1996. Let me just go back 1 year. Right? Because I know every year I was growing at that steady rate. So let's just go back 1 year to 1995. They didn't tell me what it was in 1995, but they gave me enough information to figure it out. So couldn't I, ladies and gentlemen, just take this total and subtract away from it 60,300 to get the number of people in 1995? You with me? So let's see. 3,204,000. Let's subtract off 60,300. I get the following. 3,143,700. I told you, big numbers, but still, whatever. I can handle a big number. I got a calculator right here. It does all the heavy lifting for me. But does this make sense where I got this point from? Okay. Now you have 2 points. You can finish this. Go ahead, try it. I know it's big numbers, whatever. Just deal with the big numbers. Use a calculator. You're going to do exactly what we did in the first one. Find the slope, write it in point slope form, and then rewrite it in slope intercept. Try it. Everybody try it. Okay, did we get somewhere? Did you find the slope? You kind of know the slope from the problem, don't you? The change is 60,300 every year. So hopefully that was the slope that you got, 60,300, yes? Okay, good. Once you have the slope, you pick one of the 2 points. It doesn't matter which one you pick. It's totally irrelevant. Pick one of them and stick with it though, and pop it into point slope form. So I picked the first one, 6, and then the 3 million one. So there's what mine looked like. And now all I have to do is rewrite this into slope intercept. So I'm going to distribute and add. So double check that at some point you've got what I got. And this won't matter, even if you use the other point, the 5 comma this one, doesn't matter. Once we simplify and get into slope intercept, we should all match. So does everybody have this somewhere on their paper? You do? All right, okay, good, good, good. So the next thing I have to do is rewrite this in function notation. Again, I always use X's and Y's. I should be using N's and P's, whatever. So I would just rewrite it as f of n equals 60,300 n plus 2,842,200. All right, there it is in function notation. However, I am not done yet because that is not all that they asked me. They said, use your model to estimate the population in 2018. How do I do that? How would I use this beautiful model that I came up with, Braylon? You got it. That's going to be what I plug in for n. So 2018, how many years since 1990 has it been? 28. So if we just plug in 28 for n, that should get us a rough estimate of the population of Oregon in 2018. Okay, so to answer that part of the question, f of 28. So do you remember function notation like that? Whatever you want to find, you just put it in place of n. 60,300 times 28 plus that massive number, 2,842,200. I grab my calculator, let it do the heavy lifting for me. I got I made it so messy. So I got that the population of Oregon, if it follows this linear trend, would have been approximately 4,530,600 people in the year 2018. Did you get the same? Yes. Big numbers, but so what? We can still totally do it. All right, we have one left on this sheet. Let's see. Another one with years. Oh, we like the 90s here. 1990. Retail sales at bookstores were $7.4 billion. In 1997, sales were about $11.8 billion. Right? A linear model for retail sales are in billions of dollars from 1990 to 1997. Let n be the number of years since 1990. Okay. So what are we comparing? Retail sales and number of years. So who's independent and who's dependent? Where would the number of years go? Is that going in for X or Y? Yes. And my number of years. And then my retail sales. This time they gave me both bits of information that I need. I don't need to calculate anything. They gave it right to me. The first one says, in 1990, retail sales at bookstores were 4.7 billion. That's an ordered pair. So what am I putting in for N? for this first one. You're doing this part. I'm back at this one. In 1990, so if N is the number of years since 1990, what do I put? 0. The sales were 7.4 billion. I guess we should say sales in billions. And now, Braylon, you're right. So now in the second part, in 1997, the sales were 11.8 billion. So wouldn't N be 7 this time because it's been 7 years since 1990? Yeah, so we put a 7 and 11.8. Now, ladies and gentlemen, you have all of the information you need. Go ahead and write this linear equation. You have the 2 ordered pairs. Find the slope, pop it in. Downtrodden doesn't work, right? Right? Downtrodden? We're making that up. Say, don't be downtrodden by the size of this packet. That's okay. I know. Don't be discouraged. I like downtrodden though.
It says the word.
Yeah, all right. What?
That's what it says.
What? No, I thought it meant.
Thanks for saving.
You're so welcome. I guess the third, oh wait. Okay, so let's finish this one out. You've got everything you need here. Y2 minus Y1 over X2 minus X1. 11.8 minus 7.4, 4.4 over 7. All right, so there is my slope. If you don't want to have a decimal in a fraction, which normally we try to avoid, I could rewrite this as 44 over 70, right? If I multiplied by 10 over 10. Well, it's billions per year. So now I can reduce this to 22 over 35. If you left it in decimal, that's fine. Doesn't matter. I just know some, we're so trained to not have decimals in our fractions, even though mathematically it's literally the same number. So I don't particularly care, especially because your final answer is going to have a decimal in it anyway. But what's so nice about this one, I have a year 0, so I already know what the y-intercept is. So I already know this equation of the line is just going to be whatever slope you chose. I have it in my key as the 22 over 35, so I'm going to leave that. Plus the 7.4. And then just rewrite it in function notation. So we're doing, oh my gosh, I've been a silly goose. I don't want it to be an F. I want it to be the other variable. I'm so sorry. So that one should have been a C. This one should have been a P. Oh, golly. There we go. And so then this one's going to be my retail sales, depending on the number of years, 22 over 35, X plus a 7.4. And that's it. We didn't have to find anything else, right? Nope. Cool. All right, so I just gave you this packet. You're not going to feel sad about it. You're not going to be like, oh my gosh. Don't worry, I'm not going to make you do all of it tonight. Don't worry, you silly goose. But let's look. Let's see if we can maybe get through a couple of problems on the first page. Just the first page. We'll just start there. All right, we have a bathtub problem. Let's read. You pull the plug from the bathtub. After 40 seconds, there are 13 gallons of water left in the tub. 1 minute after you pull the plug, there are 10 gallons left. Assume the number of gallons of water varies linearly with time since the plug was pulled. So what that basically means is it's draining at a steady rate the whole time. All right, part A says write a linear model expressing the number of gallons G left in the tub in terms of the number of seconds S since you pulled the plug. Don't the number of gallons depend on the time since I pulled the plug? Right? Okay, so we've determined independent, dependent. We can set up our little chart. So we're going to have number of seconds and the gallons left in the tub. The gallons depend on the number of seconds since I pulled the plug. Do I have any information to put in here? Do I have any points that they gave me? Yeah, you do. They gave you 2 points. Let's read. After 40 seconds, there are 13 gallons of water. That's a point right there, you guys. That's a point. 40 seconds, there are 13 gallons left. Do you see the second point they gave you? Be careful, don't fall into this trap, Cedric.
100.
I like the 10. I don't think you mean
Because you put 40 plus another minute. 60.
20 seconds after.
right. It's 1 minute after you pull the plug. So I don't think it's 1 minute after the 40. Yeah.
60 seconds.
Yeah, so 60, and there are 10 gallons left. But I was hoping that none of you fell into the trap of putting a 1 there, because this is in terms of seconds, right? So although it says 1 minute, that's 60 seconds, right? We're in terms of seconds here. So 60 seconds after I pull the plug, I have 10 gallons left. Now we can go ahead and find the slope. Go ahead. Now hold the phone. Did you get a negative slope? Because I did. Does that make sense? Yes, because isn't the water going down? Yes, we are decreasing the amount of water we have in the tub over time. So it makes sense that my slope is going to be negative. All right, so hopefully you went ahead and finished writing this problem. We don't have a ton of time left, so I just want to scan through this. B, it should be easy enough. Once you get your equation, you're just going to tell me after 20 seconds and 50 seconds. C, I think you can do that once you have your equation. F, you can do. D, They ask you, what does the y-intercept represent? What does the x-intercept represent? And then G, we actually just talked about that. What's the slope and what does this number represent? I would like you to finish just the first page for homework. That's it. So hopefully you have A done or almost done. Okay? Please try not to lose this packet either, because as you can see, there's a lot of pages. So we'll be working on more of them tomorrow. Please don't work ahead. I know it's tempting. We probably won't even do them all though. So if you work ahead, you might do stuff that, not that I'm ever against you doing extra. Okay, let me go open it up on Jupyter for you.
Oh, yeah. But you guys like sound the same. Like, I don't know. Weird. I've been there. Wait, no, yeah. Midnight? Yeah, but we sleep in. All the time. Yeah.